Hey trig class, in this video we're going to look at composite inverse trig functions, meaning a inverse trig function with some other type of trig function on the inside. And what often happens is if these are the same, inverse cosine and cosine, then we can oftentimes they undo one another and we just get this angle back. But that's only if this angle is between 0 and pi. Alright, so 4 pi over 5, that's 4/5 pi, 80% of pi, which means it is between 0 and pi. So this is between 0 and pi. If you want to check, just type the number on the inside, 4 pi over 5, hit enter, it'll give you a decimal. As long as that decimal is between 0 and pi, and remember pi is 3.14ish, this number is less than that, then this number is between 0 and pi. And because of that, inverse cosine and cosine will wipe each other out, and I'll just end up with the 4 pi over 5. But if the number is out of the range of this inverse trig function, then we're not going to just wipe each other out. Alright, so now we have sine. On your unit circle, the values of sine, the values of inverse sine that it can output are between negative pi over 2 and positive pi over 2. So if it goes beyond that, and you can see 4 pi over 5 is beyond pi over 2, it's too big, then we will not just be able to undo these. So what we have to do is understand what will happen. So the sine of 4 pi over 5, 4 pi over 5 again is somewhere over here. Let's say it's right here. So that is the sine of 4 pi over 5. It's the y coordinate of that point. Alright, so the y-axis, if I go up until I'm even with that point, that's this height off the x-axis is the sine. But I need to be in negative pi over 2 to positive pi over 2 if I'm doing the inverse sine, and that is the last thing I'm doing. So the angles can't be way over here at 4 pi over 5. So what I have to do is figure out what angle would this be that corresponded to that same y coordinate, but in quadrant 1. So this angle, right? Well, hopefully you can see that that angle that I just drew, switch colors, this angle that I just drew corresponds to this angle. It's the same angle. It's what gets me to that y coordinate, that the angle that I would rotate down to get back to the x-axis. And this is pi, and this is 4 pi over 5. So this inverse sine is going to return pi minus 4 pi over 5, which is 1 pi over 5, or just pi over 5. So there it is with doing a unit circle to help. Now let me show you again the trick I can do with the calculator. So I can type exactly what I see here. Second sine is inverse sine of the sine of 4 pi over 5. Close both those parentheses off, hit enter, it's going to give you a decimal. Right? And remember what we showed in the previous video, divide that by pi and then change that into a fraction. That's 1/5, stick the pi back in there, so that's pi over 5. So that's the way that I can use the calculator to either check or even do the transformation for me, getting everything back into either quadrant 1 or quadrant 4 for me. Alright, same thing's happening here. Cosine is defined between 0 and pi. Inverse cosine. Inverse cosine has to return an angle between 0 and pi. Well, negative 4 pi over 3, if you look at it, here's where positive 4 pi over 3 is. That's coming this direction. So you can see I'm going to have to go all the way around and then 1, 2, 3 special angles past, halfway around the circle, I should say. So if I do it in the negative direction, which is what it says to do here, I'm going to go all the way halfway around and then 1, 2, 3 special angles pass. So positive 2 pi over 3 is the same thing as the cosine of negative 4 pi over 3 is the same thing as the cosine of positive 2 pi over 3. That's what I'm trying to say. So the x coordinate there is negative 1/2. And now I'm being asked, okay, the second part says what angle between 0 and pi, starting here and going to here, between 0 and pi, would make the x coordinate be negative 1/2. And it is that positive 2 pi over 3. So it's that angle that would get me there. So basically the first way, this is rotating me around in the clockwise direction to that point. And then the angle that we get when we do the inverse cosine rotates me back in the positive orientation, or the counterclockwise direction. So inverse trig functions are angles, but because they are inverse trig functions, they are bounded. They have a lowest value they can be, they have an upper value they can be, and it's our job to figure out how do we get those values. Alright, so 2 pi over 3 is our angle. We can also do that again with a calculator. Inverse cosine, second cosine of the cosine of negative 4 pi over 3. Close that off a couple times, enter. Divide that by pi. That removes the pi from it. Change it into a fraction, and then stick the pi back in there. So that's 2 pi over 3. So you can do it with the unit circle, you can do it with the calculator.